Hi everyone. Welcome to paitalks. This session is Voice Agents 101. In this session, you will be able to get an idea on what voice agents are and how to go around building products with voice agents. Okay? So yeah, let's go into the presentation. Voice Agents 101. Right? So what are the index and what are the things that we are going to talk about? Is agent and a voice agent? What is the difference between a normal agent and a voice agent? Why are voice agents important? Some architecture around voice agents and which architecture to use when. What are the different components when you are building a solution for voice agent? Prompting of a voice agent, MCP, RAG and LangChain. Okay, let's proceed. So what is an AI agent, right? A AI agent is a setup wherein there are model, instruction, tools that can pursue, reason and take actions to achieve a goal without the developer writing manually every step. So you don't need to write everything step by step. Okay. So yeah, when I started my AI journey or understanding AI, I used to think that LLM and AI agents are same, right? But that is not the true actually. Okay, LLM is different, agent is different. Agent can do end-to-end things on their own. So AI agent has model, it can take your instructions and using tools it can do things end-to-end without you doing every step of it. That's the difference between an agent and an LLM. Okay, an AI agent is an AI that doesn't just respond, it decides what to do next and does that action, right? LLM won't be able to decide what to do next and do that action that an AI agent can do. So what does an AI agent do, right? It understands the user's request, like what is the intent of that request. It can think about how to solve it, it can plan, it can do an action by calling the tools, APIs, functions or other agents. It can observe the results, and if the results are not as per expectations or as per expectations and there is some next step, it can even do that next steps. Okay, so this is a difference between a normal LLM or chatbot which just gives an output text. You ask a question, it gives you output. That is an LLM. But an AI agent has external powers actually to perform other tasks. Yeah. Now you have understood the difference between an agent and a uh, LLM, right? Now let's come to why voice agents, right? There is LLM, you make him a chat agent. Chat agent is able to do things, it can call action tools. But why are voice agents important? Why you should think and build voice solutions, right? So you generally speak 3x faster than you type. Voice is the most natural interface, right? Whatever you do, anything you do, voice is the natural interface. Human think and communicate in speech. Speech is a natural reflex, not text, right? Voice agent function like an API to the real world. Voice agent, that's an API to the real world. So your software can interact with human, business, real world processes through natural conversations. That is the experience that we need to make through voice agents, right? Chat is everything, it stays within the app, it's not natural. So what is voice agent, right? Voice carries tone. It carries the tone, how you are speaking. It carries the urgency, like you can understand here how fast or how urgently the user needs it. There is a lot of sentiment in text, lot of sentiment in voice, sorry, not text. There are pauses, there are stress. Everything of it you can sense with voice, which are not there in chats, right? Voice agents can personalize responses better by understanding how something is said, not what is said, right? What is said is present on your chat also. What makes voice difference is how something is said, right? So let's come to the architecture part now. So there are two types of architecture, chained architecture and speech to speech real-time architecture. Okay. So what you have to do is let it be voice agent, any AI solution that you want to design, right? Things are available on the internet. You should go on the internet, you should understand what are the best practices, how are people doing it, and then you should come and as per your product you should implement it. Okay, so when I have to build something around voice agent, I went to the internet, I saw what are different architectures available. So voice agents, currently two architectures available, chained architecture and speech to speech real time architecture. Okay, So what is a chained architecture? Just let's go through the flow diagram here. User audio comes, there is an app then there is an app interface. Then what happens in the backend? There is a speech to text model. So speech changes to text here using this one model. Then there is a text based model. What does this model do? It has all the respective tools, right? Function, search, handoff is there. So the tool is, so text, this is like a LLM. Then there is an agent that can do tool calls here. Okay, so text does all the call. Then again, once we get a response, text goes to speech, and speech again app, and the voice as a output. So this is a voice to voice agent, right? There is in middle, there is a text conversion. Text LLM does all the work here, text agent. Okay, what is other way of doing it? Other way of doing is speech to speech. Audio comes in, app is there. There is a speech to speech model here. There is no, we do not convert speech to text here. This directly speech to speech. Speech to speech model understands the audio, makes the tool call, goes to the app, gives the output as the speech, right? So this is the difference, and these are the available engineering style or architecture that you can see for voice agents right now. Okay. So let's try to understand when you have to go with chained architecture and when you have to go with speech to speech architecture. Okay. Chained architecture. What are the pros of chained architecture, right? It has full control over every step. So voice becomes text, text becomes, your text does all the things. Every step you have control over. You are engineering every part of it. Better accuracy checks, right? You can check what went wrong where. Predictability is high because you have better control. Easy debugging. Every step, if there is an error, you can debug it. Optimize cost. You can use models cheaper at some instances, higher because you are using different models, right? Cons. Con is latency is high because there are three models: speech to text, text doing the work, then again text to speech. Latency is high. Loss of audio data. Any conversions come with a loss, right? Speech you are converting to text. There is some loss possible there. Difficult to manage interruptions, right? When you are using that model. Chained architecture, what generally happens, you take some pause, the model, you are not able to detect that model properly, you miss some words, important words in between. So that is a problem with chained architecture, right? But now let's try to understand for what type of thing you will use chained architecture. Okay, chained architecture. So let's try to understand this last sentence first. You rely on speech to speech model to hear rightly. You can validate what it outputs, but not how and what it heard. So problem with speech to speech model is you cannot validate what it has heard, right? How it hears it, what it has heard, because directly output is something that you have power over. Ki output right or wrong it is, but the control part is here. See, speech to text. So you have control around what it has heard. You have converted into speech. So speech you can change afterwards, but here it is directly just what the voice model has heard. Okay. So let's come to the problem statement. My monthly income is rupees 20,000, EMI is 5,000, I have one credit card, CIBIL is 700, and I want a loan of 3 lakhs for 4 years. This is the problem statement. Now you consider this, there is a loan application of a bank, a user is speaking with it, and the model or the voice application has to give an answer whether he is applicable for loan or not. Okay. So see what will happen. The person will say this sentence. Our speech to text model will extract all important things: income, EMI, CIBIL, request amount, what is the month he requires the loan for. Multiple API calls have to pass different values in different APIs. So this is a complex, right? There are multiple API calls will be the CIBIL API will be different, EMI API will be different. There will be some validation APIs. So, and this is serious. Like once you say that a loan is given, that means you have to give that loan, right? So in such instances, latency, we can tell the person, please wait for some time, we will get back to you. This is not a direct wherein we need to be quick. Here accuracy is important, right? So wherever latency is fine and accuracy is very important, chained architecture comes into picture. What can go wrong here, right? If in speech to speech model, you don't have a lot of control because model hears, it automatically processes things and gives you an output. There is no speech to text conversion available here for you to interrupt here. So wherever accuracy is high, you go with chained architecture. Now let's come to speech architecture, right? What are the pros? Latency is very low because one model does everything. User experience, right pause is very human, right? It can sense the pause, it can understand things because it can understand interruption very well. Quicker engineering, because you don't have to do separate parts, there are already models which are done very well, right? What are the cons? Less control or transcription, like speech to text control, there is no control here. Harder to debug how the model is interpreting, what is going wrong there. There is debugging is very less scope here. Okay. So wherever consumer applications are there, where latency is the key, like you need quick responses, you need better understanding what user is saying, speech to speech comes into place. So I hope till now you have followed and you have understood what are the different architectures available and which one to use for your products, right? Now I have told you speech to speech, I have told you chained architecture, right? But how do you make speech better, right? Now there is always an engineering, you're trying to make the best outcomes possible, right? So how to make speech to speech agent setup better? So what people are doing now is they are saying user audio will come, there will be a frontline voice to voice agent. Okay, this voice to voice agent has just one work, to take input and to give output. All the processing it will give tool calls, refund, there will be different agents, refund will be a different agent, product expert will be a different agent. So what this will do, whenever it understands, okay, this is the intent, it will make a tool call, give that to the owner agent, agent will give, it will give output, then our frontline agent is able to give their answer, right? So what is the current problem of speech to speech, right? Lot of hallucinations, model if the prompt is very big, it won't be able to give answer correctly. So by doing this, we are reducing the load on the speech to speech agent. We are saying, okay, you just focus on giving the right answer, let the expert agent give the thing and you give the answer, right? By this we are solving the problem of accuracy here. There will be very less hallucinations, very less problem of errors here, right? I hope till now it's very clear, and also this part is clear around how we are doing a better job with speech agents, right? Now let's come here at different components in voice agent, right? Now we have understood all different parts of voice agent. Now let's come around what are the different parts when you're thinking of voice agent, you should remember. One is the system architecture, what architecture you want to do as per your use case. Prompting and instruction, right? Very important. How to behave, what to do. Is the agent's personality plus rules. Prompting is very important. Tools. You are going to use MCP, you are going to use RAG, you are going to use APIs. What are all the external abilities required for your agent? You need to scope this out, right? What are evals? Evals are automated test cases that check whether the AI consistently behaves appropriately as per your expectations or not. So evals are very important. So just launching product does not make sense, right? You should be able to evaluate it whether it is able to do the right things or not as expected. Guardrails, right? Guardrails keeps the AI safe and on track by preventing wrong actions, bad outputs, or policy breaking responses. So while AI voice agent gives response, you will have some guardrails such that it is not giving answer that is not expected or something that is completely wrong. So some protection protocols type of a thing. Delegation, right? The agent stays in control but asks for help from other tools, like this example that we see. Agent is in control but it is asking help from other tools. So delegation is very important. This is another concept that you should remember when designing your products. Handoff. Handoff is the smooth transfer of control from one agent to another agent, right? Completely different. You just hand over. Delegation is different, handoff is different. In delegation, you are the power authority, you are just getting things done from other tool. Handoff, you're completely giving your power to someone else. So yes, I think these are all the different components. If you do them right, I think you are good. Okay. Now this is a small fundamental example which you can understand the workflow, right? Now we have understood the theory. Now let's do a practical example. So there is an agent, there is weather question, and this is the agent that I have written here. Okay. So let's say user says, what's the weather in Mumbai? Okay. This user message comes here. First, when the user message goes into the agent, we understand the intent of the user, right? LLM, intent. Intent is what? If intent is not equal to weather. So let's go this. What's the weather in Mumbai today? If intent is not equal to weather, no tool call, just answer. Okay. But intent is weather here. Okay. Intent is weather. So it will come to the next step. City, LLM decision city. Okay. Okay, I take the city from here. Okay, so Mumbai it is. If not guardrail city, okay, guardrail can't be fetched. Guardrail is there. If not guardrail, I go to the guardrail function city. Okay, what is city here? Mumbai, Delhi, Goa is in allowed. Okay, so it is in allowed. So this also function won't be called get weather. So weather in Mumbai is sunny. So I am able to answer this first question, right? I am able to go all the steps. I hope this is clear. What's the weather in New York? So I go here again, New York, intent is again weather. I skip this. City is equal to LLM decision, New York. If not guardrail, I go to this allowed. New York is not here, right? So city dot lower is in allowed. So guardrail can't fetch weather for this location. So this is the error message that will go to the user, that we cannot fetch weather for this location. Okay. So this is how you set a guardrail. Like the person might be wanting that only Indian places should be given an answer. Only these 4 places the answer should be given. Rest of the places the answer should not be given. So this is the guardrail that the user has set here. Okay. Tell me something funny. It will go here intent is not weather here. So no tool call. We just answered the user. So this is how you implement things, right? So guardrail is implemented here, function call is tool is implemented here, right? This is a tool wherein one agent is giving power to some other tool to give me the answer to this question, right? So I hope this example is clear. You understand the intent of the user. As per the intent, you have the guardrails, or you can make a tool call, get the answer and reply to the user. Yeah. Prompting for voice agents is very important. And yes, I came across some articles, some tool like openai.fm, right? I have present the link here. I think this is very helpful. You understand what are the different voice models available, how to write better prompts. On their website, they have also mentioned some of the levers to write prompt, like tone, level of enthusiasm, level of formality. So I think writing good prompt is very important. You can explore this site and understand. Yeah. Let's come to the MCP part next. I think theory around voice agents is very clear and I think we are good with it. So let's come around MCP. MCP is Model Context Protocol. ये बस नाम कॉम्प्लेक्स है, बाकी सब आसान है इसमें. ओके. MCP is a standard way for AI agents to talk to external tool, APIs, database safely in a structured manner. Okay. तो लोगों ने क्या किया है, एजेंट्स आर देयर, एजेंट टॉकिंग टू टूल्स, एपीआईज इज वेरी कॉमन फंक्शनलिटी. सो पीपल सेड लेट्स मेक अ स्टैंडर्ड वे ऑफ डूइंग इट. दैट इज एमसीपी. ओके. इट्स लाइक अ यूएसबी फॉर एआई टूल्स, a universal plug so that any model can talk with that tool. MCP is the language that tools and agent use to talk to each other. Okay. So when does MCP come into picture, right? So if there are multiple tools, multiple APIs in organization or the project you are building, and there are multiple agents. Now agents have to talk with these multiple APIs every time. So you will have to integrate the APIs again, right? To avoid this, we have an MCP. Build an MCP once, let there be any agent, they can talk with that same MCP. That is basically major use case of MCP. Yeah. I hope this is very clear. MCP is a type of a layer. Behind that layer there are all the tools. Any agent can call that MCP, okay, and get the tool that they want. What is RAG, right? Retrieval Augmented Generation. RAG is a technique where AI does not rely on its memory only, right? It first retrieves the correct information from your data and then generates the answer based on it. So it will depend on your data and it will give an answer as per your expectations, right? So how does a RAG thing generally works? So any data embeddings are created. What is embedding? Vector DB is made. So vector DB all embeddings are stored. What are embeddings? Embeddings are numbers that represent meaning, right? A vector DB stores embeddings so you can quickly find which documents are closest to the user question. Okay. So how does a RAG generally work? It converts your documents to embeddings and store them in vector DB. आपकी जो भी documents से embeddings करके vector DB में डाला. Convert to user query in embeddings. Okay. Embeddings, what it does is all the words which are similar, it keeps them very close by in the vector DB. User asks question, that is converted to embeddings. Top and closest vectors are searched. We get those, retrieve those documents, give them to the LLM. LLM answers as per the information given, right? And sometimes I get this question, are embeddings always important? Mostly embeddings are followed. Embeddings is the better and right way of doing it. But yes, Without embeddings also you can do RAG. In simple words, okay, these are all complex names made to scare people. RAG, matlab, some people I have met, and even me myself used to get scared, like, what is this RAG? It's something complex kya? No. Just think RAG as in the database, it's a database that access is given to the agent. You ask something to the agent access that DB. It's just that database actually access. That's it. What is LangChain, right? Another fancy term, LangChain, right? Nothing to worry. LangChain is an orchestration framework that connects LLM with tools, APIs, database, and workflows. Just how React is a framework, right? Same way, LangChain is a framework that helps connecting LLMs with tools, APIs, database, workflows. It helps AI break down complex tasks and choose the right tool, run multiple processes, respond to reliable outputs. That is what LLM is. That is what LangChain is. It's just a framework. Okay, LangChain can be used anywhere. Okay, it is a framework, orchestration framework basically, that helps connect LLM, APIs, tools, and everything. Okay, LangChain with MCP. What does MCP does, right? MCP I have told earlier, it is a tool definition. All tools are mentioned there. There is a input output schema, like these tools require this input, right? Validation is there, providing a tool list to the agent. That is what MCP does. MCP cannot do RAG. RAG cannot be done by MCP. SOP search cannot be done by MCP. Multi-step workflows, do this, then do this, then do this. MCP cannot do that. Complex data transformation is required. MCP cannot do that. API orchestration is required. Call this API, then call this API. MCP cannot do that. And this is where LangChain comes into picture. LangChain can do all of it. LangChain orchestrates everything. It keeps things together, right? Consider React, right? You have components, you have all the different code bases that you have, files you have. React is like a framework that helps you put everything together. It gives you some easy components, direct components to install and directly use, right? So that is what LangChain is all about. Now let's do an interesting example, okay? After this, you should go ahead and you can build any voice agent, or at least you can put a structure for any voice agents. So user speaks, मुझे बटर पनीर और 2 गार्लिक नान ऑर्डर करना है, चीपेस्ट प्राइजेस. देर इज़ अ वॉइस एजेंट. नाउ यू आर स्पीकिंग, यूजर स्पीक्स, ओके. मुझे बटर पनीर और 2 गार्लिक नान ऑर्डर करना है, चीपेस्ट प्राइजेस. देर इज़ अ वॉइस एजेंट, स्पीच टू स्पीच. इट कन्वर्ट स्पीच टू टेक्स्ट, डिटेक्ट्स इंटेंट. व्हाट इज द इंटेंट? प्लेसिंग ऑर्डर इज द इंटेंट. एक्सट्रैक्ट्स आइटम्स, बटर पनीर 2 गार्लिक नान. इट डिसाइड्स टू कॉल द MCP टूल. Find cheapest order is the tool that I want to call here. MCP layer is there. Find cheapest order, item and location I pick up. Validates the schema whether all the requested things are passed. Forwards request to backend implementation. Okay. Now here is where a LangChain is, right? It's the orchestration framework. It's the smart guy out there. So find cheapest order item. Inside the tool LangChain does. Okay, LangChain is working now. Call restaurant API. LangChain says call restaurant API. Restaurant API is called. Get menus, prices from multiple restaurants, get delivery fees. Okay, so we call restaurant APIs, we get their menus, we get their prices. LangChain LLM plus thing, we normalize the menu here. We need to butter paneer, paneer butter masala, all these things will be written. We need to make them standard, group things that are same. Consider combos, thalis that include these items. Compare total food price, delivery charges, available coupons. Pick the lowest final bill. Okay. Then after doing all of this, we get an answer. Spice Hub is the restaurant, this is the price overall. MCP checks whether this output is fine or not and passes to the speech to speech voice agent. Okay, speech to speech voice agent kya? He is just the talking part of it. He takes the output, it says, it generates a user friendly response. सबसे सस्ता ऑप्शन स्पाइस हब से आ रहा है, टोटल रुपीज इज दिस, डिलीवरी 30 मिनट्स में होगा, ऑर्डर प्लेस कर दूँ. सो दिस इज व्हाट वॉइस एजेंट विल स्पीक. User will say, हाँ place कर दो. Again the same process will start. MCP tool, confirm order is the function. Backend places the order, returns confirmation. Voice agent will say order place हो गया है, delivery 30 minutes में आ जाएगा. Okay, this is how you go around building voice agents. Now here itself on the call we have built a solution for restaurant voice agents, right? You can go ahead implement it. Okay. So that's all folks. I think this video gives you clarity around building voice agents. If you like this, do subscribe to paitalks, do like, do put down any doubts or questions you'll have. Yes, and that's it. And you all can, this presentation I'll put on paitalks.com, so you can, yes, go to the site and have a look at it. Yeah, bye guys, have a good weekend.